Today we're going to be looking at geometric sequences. All right, to start off with, here's your standards. And to be successful, you need to be able to determine whether a sequence is arithmetic, geometric, or neither. You also need to be able to write and graph the terms of a geometric sequence and write geometric sequence as functions. So these are the things that you need to be able to do by the end of the lesson. A couple vocabulary words, make sure you put these in your notes. In a geometric sequence, the ratio between each pair of consecutive terms is the same. A common ratio, the ratio in a geometric sequence. Each term in a geometric sequence is found by multiplying the previous term by a common ratio. All right, a couple key ideas that you need to keep in mind. Again, this is your geometric sequence and your common ratio is discussed here. All right, you can see this is a sequence 1, 5, 25, 125. To get to the next term, you multiply by 5. That 5 would be considered your common ratio here. And these would be the terms of a geometric sequence because you're multiplying to get to the next term. That lets us know it's geometric. Remember when we looked at arithmetic, you had to add or subtract to get to the next term. Now we're multiplying to get to the next term. All right, so a key idea, an equation for a geometric sequence. Let a to the n be the nth term of a geometric sequence, and the first term, a subscript 1, and a common ratio r. The nth term is given by a sub n equals a sub 1 times r raised to the n minus 1 power. All right, so this is your general equation for a geometric sequence. So we're going to be using that as we go along. All right, the first thing is you need to be able to identify a geometric sequence. All right, so we kind of looked at the terms, and you have to see, can you multiply something by a common ratio to get to the next term? An easy way to do that is look at each one of these and divide it by the previous term. 60 divided by 120 is 1/2. 30 divided by 60 equals 1/2. And 15 divided by 30 also equals 1/2. So you can see that there is a common ratio here. So that means this is a geometric sequence. All right, B part, we have 2, 6, 11, and 17. All right, so to get from 2 to 6, I'm going to add 4. From 6 to 11, I add 5. And from 11 to 17, I add 6. So there is a pattern here, but there's not a common difference, which means it's not arithmetic. And there's not a common ratio, which means it's not geometric. So B part, even though there's a pattern, you could probably determine the next 3 numbers based on the pattern, but it would be considered neither arithmetic or geometric. All right, does the sequence in example 1a eventually reach 0? Explain your reasoning. All right, so this goes 120, 60, 30, 15, so it would be 7.5 and then 3.25. It's going to get smaller and smaller and smaller, but it's going to continue to be a fraction when it gets very small. So it will never reach 0. It will approach 0, but it will never reach 0. All right, for example 2, we're going to extend a geometric sequence. So if you can find the pattern, if you can find the common ratio, which determines what you're doing, then you can use that to get to the next term and the next term and the next term. So it says write the next 3 terms of the geometric sequence. So we have 3, 6, 12, 24. So what are you doing? It's doubling each time. So what does that mean? That means I'm multiplying by 2. So my common ratio is 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So if I want to get to my next 3 terms, 24 times 2 is 48. 48 times 2 is 96. And 96 times 2 is 192. All right, make sure you check my math there. I think that is correct. All right, B part, 64, -16, 4, and -1. All right, so let's look at the calculator here. Looks like 1/4, but let's double check and see what that's going to look like. So take my second term, negative 16, divide it by my first term, 64. All right, negative 0.25, so that is negative 1/4. Then do the third term divided by the second term. Hopefully that is negative 0.25 as well. There it is. And then negative 1 divided by 4 is also, oh, I had the answer here, sorry. Okay, so I just need negative 1, not the answer negative 1, just negative 1 divided by 4. And that's going to give me 0.25 as well. Okay, so somehow I had clicked the answer here. So when I divide these, I get negative 1/4. So my common ratio here is negative 1/4 or negative 0.25. And so I can write the next three terms by multiplying each one by negative 0.25. So if I have negative 1 times negative 0.25, that's going to be 0.25 so this is going to be, I'll write it down here, 0.25, and then I need to multiply that by negative 0.25, so 0.25 times negative 0.25. So my next one's going to be negative 0.625. And then take that, take my answer and multiply that by negative 0.25. And that's going to be my third term, 0.015625. All right, you also could write these as a fraction if you wanted. So you know 0.25, that is just 1/4. Negative 0.0625, that would be negative 1/16. And this 0.015625, that would be 1/64. So either way would represent your next three terms of a geometric sequence. Example 3 says to graph the geometric sequence 32, 16, 8, 4, and 2. All right, so we know that this is my first term, second term, third term, fourth, and fifth. So if you know which term it is, then you can graph it using n as your term here, and then put a to the n up your side, or your vertical axis. So we got 1 and 32. So if I come over here, 1 and 32, put a point here. All right, 2 and 16. So here is 2 and 16. And then 3 and 8. Four and 4. So my fourth term is 4. And then 5 and 2. You can see that's going to get smaller and smaller. Those will become fractions, and it's going to look like an exponential decay. But we only graph the points here. We don't connect the dots because we're just graphing this sequence. So the points in between here are not part of the sequence. And the study tip here says the points on any geometric sequence with a positive common ratio lie on an exponential curve. So it is going to look like an exponential curve each time you graph in geometric sequence, as long as you have that common ratio. Example 4, write an equation of the nth term of the geometric sequence. So we've got 2, 12, 72, and 432. Then find a to the 10th, or a sub 10, or our 10th term is what it really is. A 10 is just our 10th term. All right, so key idea here is a reminder of the general equation. So let's go ahead and write that down. So if I need the nth term, then I'm going to need my first term times my common ratio raised to the n minus 1 power. All right, so the first thing we need to do is figure out what our common ratio is. So again, if we look at this, we can do 12 divided by 2. That's going to be 6. 72 divided by 12, that is 6 as well. And 432 divided by 72 is 6. So our common ratio is 6. And again, 2 times 6 is 12. 12 times 6 is 72. And 72 times 6 is 432. So if we work backwards and look at the division here, remember division and multiplication are inverse properties. So this is an easy way to determine the common ratio if you don't just look at it and see the pattern. All right, now a sub 1 is our first term. So we can see here we have our first term, and now we have our common ratio. So we're going to have a sub n equals 2 times 6 raised to the n minus 1 power. All right, then it says find a of 10. So we're going to look for our 10th term. So a sub 10 equals 2 times 6. N is going to be 10. So we're going to substitute 10 in place of n. And then we're just going to simplify. So we're going to do 2 times 6. 10 minus 1 is 9. Remember, you've got to do order of operations. However, the calculator will probably do this for you. So let's do 2 times 6 raised to the 9th power. All right, so I'm going to do 6 to the 9th power. I always like to double check just to make sure I don't just automatically trust the calculator to do order of operations. It does when you type it in correctly, but if you don't type it in correctly, and I'm always worried I'm not going to type it in correctly. All right, so what was that number again? All right, so you have a geometric sequence. Here's our geometric sequence. If you keep expanding this to the 10th term, this will be the number in place of your 10th term. All right, the study tip, notice that the equation a sub n equals a sub 1 times r to the n minus 1 power is of the form y equals ab to the x power. Remember, this is your general form for an exponential equation, and this is also just another form for an exponential equation.